All right, today you're going to need your note packet and your own set of notes, both. So if you can find this page in your notes, it says derivatives, inverse functions, and exploration. I'm going to start with that. Then I'm going to move to your own notes. I guess you could write it on the back of this page if you really want to. And then near the end, we might also start talking about these notes, some inverse trig review. So have those out. And when you're ready, here we go. So I'm going to be honest, today's lesson is a little weird, and hopefully it'll make sense. If it doesn't, feel free to ask me questions. It took me a couple years to fully get it, but good news for you, I feel like I fully get it now, so hopefully that'll make more sense than when I originally taught it. Anyways, here we go. It says let f of x equals x squared. X is specifically bigger than or equal to 0, so we're going to keep that in mind because that's going to help us in a second here. And here's the important piece. I'm going to call g of x equal f inverse of x. So g of x is going to be the inverse. So first question says find g of x, f inverse of x, or f prime of x and g prime of x. Okay, so we're going to start with g of x. And remember, g of x is just what I'm calling the inverse. So if I want to do that, how do I find an inverse? What's my first step? Switch x and y. So instead of y equals x squared, we're going to have x equals y squared. And solve for y. So I take radical of both sides. Now technically that'd be plus or minus, but since x is strictly greater than 0, I only have to worry about the positive square root. So it's going to be y equals the square root of x. And you can think graphically too. If I just have positive x's for x squared, there's my original graph. So the inverse graph would just be that piece of it, which is the positive square root. Okay, next it says to find f prime of x. So if I want to find f prime of x, well, that's easy. If f of x is x squared, what's f prime of x? Right, 2x. Okay, and then finally find g prime of x. Okay, well again, g is f inverse, so this one over here. So that means g prime of x. I didn't want to think of that as x to the 1/2 power. So that'd be 1/2 x to the negative 1/2, which I would rather write as g prime of x equals 1 over 2 radical x. Okay. Now it says complete the table. So you could use your calculator if you wanted, but these are pretty easy to do. So f of x, remember, is just the original equation, x squared. So 0.5, 1/2 squared, that's 1/4. 1 squared is 1. 1.5 is like 3 halves, so 3 halves squared would be 9/4. 2 squared is 4. 3 squared is 9. 4 squared is 16. There we go. F prime of x, which was just 2x. 2 times 1/2 would be 1. 2 times 1 is 2. What's 2 times 1.5? It's 3. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Okay. And the last column's a little weird. It's g prime of f of x. So maybe we should talk about what that is. Let's change to red here. So g prime of f of x, which was x squared, would look like 1 over 2 radical, plug in x squared. Radical x squared is just x, so it's 1 over 2x. Okay, so 1 over 2x, well, you could do it 2 ways. I could plug in 1/2 here. So that'd be 1. 1 over 1 is 1. 1 over 2 times 1 would be 1/2. 1 over 2 times 1.5, again, 2 times 1.5 is 3, so that'd be 1/3. 1 over 2 times 2 is 1/4. 1 over 2 times 6, or sorry, 2 times 3 would be 1/6. And 1 over 2 times 4 would be 1/8. What do you notice? Well, the numbers in this third column and the numbers in this fourth column are reciprocals of each other. And you can see that from the equations too. 2x versus 1 over 2x. That's reciprocals. So how are the two numbers related in the last two columns related? These ones and these ones. They're reciprocals. And make a conjecture about the relationship between f prime of x, so this third column, and g prime of f of x, if f and g are inverses. So remember that this whole table relied on the fact that f and g, these two functions, are inverse functions. So the conjecture is, it turns out to be always true, if f and g are inverses, then g prime of f of x, which was that fourth column, is equal to 1 over f prime of x. Okay, so let's talk about where that comes from for a second. This fourth column was g prime of f of x. This third column was f prime of x. We said they're reciprocals, so this fourth column, this is saying the fourth column is the reciprocal of the third column. And you can see that just by our work too. G prime of f of x was the reciprocal 1 over f prime of x. Okay, so it's weird because to me, why would this be true? I don't know, but just looking at this example, it seems like it's true. So you can hopefully just agree that it looks like it's true. And I'm not going to go through the formal proof of it. This is kind of a informal exploration that shows that they're probably true. But I think that's why this is weird to me. That just intuitively, why would this be true? It doesn't necessarily make sense, but it's something that can be helpful for us. Okay, so let's switch over to your own notes for a little bit. And this is the official start of day 117. You can call this derivatives involving inverse functions. Okay. So what we're looking at, and what we just looked at, is the relationship between f of x and f inverse of x and their derivatives. And the theorem is basically the conjecture we just made on that last page. If g of x is the inverse of f of x, and I think they do that just because if we use the f to the negative 1 power, that f inverse notation, and then start taking derivatives, f to the negative 1 prime, it just starts getting ugly. So that's why I do this. And both are differentiable. So you have to be able to take the derivative of both. Then g prime of f of x is equal to 1 over f prime of regular x. Now, I put that x as a red line, our red variable, and I'm going to actually change this f of x in here to green, just to show you that those are kind of two different values. This is the x value, and this is the y value of f at that x value. I'll come back to that idea in a second. But why are we even talking about this? The advantage of this theorem is that we can evaluate the derivative of the inverse without actually finding the inverse. Okay. Now, before I go any further, I want to kind of show you what I mean by this statement here. Okay, so let's try an example and I'll try to show you what this is accomplishing. Okay, assume g of x is equal to f inverse of x. Find g prime of negative 1 if f of x equals 2x plus 3. Okay, that's what the question would look like. So let's say you didn't know this formula at all. No idea. So if I want to find g prime of negative 1 and I know g of f is f inverse, if you didn't know anything about what I just talked about, how would you maybe start that? Okay, well, if g is the inverse, maybe I should find the inverse first. Okay, so I could say since g of x is f inverse of x, let's find the inverse. So instead of y equals 2x plus 3, we want to do x equals 2y plus 3. Okay, so I'm going to solve for that. We have x minus 3 equals 2y. Divide by 2. Okay, so I'm going to get y equals 1/2 x minus 3/2. Or in other words, g of x equals 1/2 x minus 3/2. Okay, so that's the inverse. Now I want to find the derivative of that at negative 1. Okay, that's easy. G prime of x is 1/2. So g prime of negative 1 would just be 1/2. Done. All right, and it's totally fine to do it that way if you can. Now notice that to do that, it relied on me being able to take the inverse. If it's a linear function, it's soup easy to take the inverse. And then take the derivative of that answer and plug in what they asked me for. Not that bad. Let me just show you the other way. So the other way would be, okay, I want to find g prime of negative 1. This formula says if I want g prime of some number, that's going to equal 1 over f prime of a different number. I'd use different colors here because x is not the same as f of x. So the thing in the parenthesis, negative 1, isn't x. It's f of x. So this should equal 1 over f prime of some number that I don't necessarily know yet. Here, let's even color code it again. Here's the negative 1. Now let's think about what that represents for a second. If this is negative 1 and that's f of x, let's make a table. Here's x, here's f of x. If I want to find g prime of negative 1, match that up in the formula, that's the green piece. So negative 1 is f of x, the y value in other words. And the x in here is some x value that goes with that y value in f of x. How would I figure out what this x value is? Well, I would plug it in to this formula, but negative 1 would be the f of x side. It's the y value. So kind of just over here for a second, I got to say negative 1 equals 2x plus 3. I got to find the x that goes with that in the original function. So subtract 3. Negative 4 equals 2x. And divide by 2. X is negative 2. So the x value that goes with that negative 1 that I was looking for is negative 2. That's what's going to go down here. Okay? Because remember, they're inverses of each other. So if I'm looking for g prime of negative 1, that's an x value of the inverse function. So it's kind of like this negative 1 is the x value that I'm looking for, sure, but in the original function it was the y value. Does that make sense? Tricky. Okay, now to evaluate this, I just got to find 1 over f prime of negative 2. So I got to take the derivative of f. So let's find f prime of x. That's going to be 2. So what would be f prime of negative 2? Also just 2. So the answer is 1/2. Because f prime of negative 2 is 1/2. What do you know? Same answer. So in the long run, this is a lot less work. That's one advantage. Another thing is that it's almost critical to do it this way sometimes because this relied on me finding the inverse. What if I was in a weird equation that I couldn't find the inverse of that I'm going to show you in the next example? Then it'd be impossible to do it this way, and you'd have to do it this way. Because what I did here all dealt with f. I never dealt with g at all, never found the inverse. That's what I mean by the advantage of this theorem is that we can evaluate the derivative of the inverse without actually finding the inverse. Got it? Okay. Incidentally, when you go to do the homework tonight, worksheet 7.3, I just did question 1 on the homework. It says find a formula for g of x. We did that. We found the inverse. Then it says find a formula for g prime. We did that. Right here. We found that g prime was 1/2. Evaluate g prime at the given value using your answer to part B. So for number 1, I wanted to find g prime of negative 1. We did that using the g prime formula right here. Then part D, evaluate g prime of x at the given value of a using that new formula. That's what I did over here. That was part D. So when you go to do this homework, I think it's worth doing number 1. I didn't tell you it was when we were in the notes because I want you to redo it. See how I did all those parts because it can be tricky for people. And then you might know how to do the rest of them. Okay? All right. So let's keep doing some more examples. I'm going to flip my page. Here's example 2. Assume g of x equals f inverse of x. Find g prime of negative 3. If f of x equals x squared minus 4x minus 3 with x greater than 0. Okay, so I'm going to just rewrite that formula off to the side because I'm on a different page now. Remember g prime of x, oops, I don't like that. G prime of f of x is 1 over f prime of regular x. So just keep that formula in mind. Okay. So let's talk about it for a second. If I did it the long way, I have to first find what g of x is. It's the inverse. You switch x and y, finding the inverse of this is super annoying because you'd have to complete the square. You'd have x equals y squared minus 4y minus 3. You'd have complete the square. You'd have plus or minuses. Blah, awful. So this is why this formula has an advantage. I don't have to find the inverse if I use this formula. My goal is I want to find g prime of negative 3. So the derivative of the inverse at negative 3. I know that's going to equal 1 over f of something. I just don't know what that something is yet. Because remember, if this is x and this is f of x, that negative 3 value is f of x. The inverse of g, this would be x, and this would be g of x. We switch the x and y's. I got to find the x value that goes with negative 3 because that's what's going to go here. Okay, so off to the side, how can I do that? I can set negative 3 equal to x squared minus 4x minus 3. If I solve that, we're going to get 0 if I add the 3 over, equals x squared minus 4x. Pull an x out. I get x equals 0, x equals 4. I've got two answers. What do I do with that? Well, we look at this handy little thing up here. It says my x value is supposed to be greater than 0, so it's not that one. It's this one. So 4 is the x value that went with negative 3. So if negative 3 was f of x, 4 is x, so 4 goes in here. And I forgot the prime there. I put the prime there. Just got to do 1 over f prime of 4 now. Well, before I can do that, I got to figure out, well, what's f prime? So maybe here I'll write quick, what's f prime of x? That's 2x minus 4. So what's f prime of 4? 2 times 4 minus 4. 8 minus 4 is 4. My answer is 1 over 4. Okay? Again, not a ton of work if you realize what you're doing. We never had to find the derivative. I never had to switch x and y in this crazy formula and use complete the square. Got my answer a lot quicker. Okay, let's try a couple more. Example 3. If f of x equals 2x plus 3 all over x plus 3, and g of x equals f inverse of x. I got to tell you that part. Find g prime of 3 halves. Now let's talk about our options for a second. My goal is to find g prime of 3 halves. I could do the long way. This one I can find the derivative of this. I have to use quotient rule, so it wouldn't come out nice right away. And once I do, when I take the inverse, I wouldn't need quotient rule. I would just have to switch x and y, do a little algebra manipulating. It takes a little bit. But then to find the derivative of that, I'd have to use quotient rule. And then I have to plug in 3 halves. Doable, just a little long. Let's do it our new way. G prime of 3 halves should equal 1 over f prime of something. How do I figure out what that something is? Well, this is the y value, or the f of x value of the original function. So I would set 3 halves equal to 2x plus 3 over x plus 3. Because I know that right now, here's x, here's f of x. 3 halves is the f of x value. I'm trying to find the x value that goes with it. Okay, let's cross multiply. We'd have 3x plus 9, I multiply there, equals 4x plus 6, I multiply there. Subtract, I get 3 equals x. Okay, so 3 was the x value that went with 3 halves. That's what goes here. Well, now to evaluate it, I got to find f prime. So I am still stuck using quotient rule. So f prime of x is bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. Let's clean that up a little bit. F prime of x is equal to 2x plus 6 minus 2x minus 3 if I distribute all over x plus 3 squared. And the two x's would cancel. I'd get 3 on top over x plus 3 squared on the bottom. That's f prime. So what's f prime of 3? Well, that's just 3 over 3 plus 3 squared. It's 3 over 3 plus 3 is 6. 6 squared is 36. So that's 1/12. So my answer here would be 1 over 1/12. What's that equal? It's a complex fraction. Multiply top and bottom by 12. We get 12. Okay? Again, weird, but once you do it a couple times, it's not that awful. Okay, I'm going to give you one final example. If f of x is equal to x squared plus 2x minus 3 with x greater than 0, and g of x is equal to f inverse of x, find g prime of 5. Okay, so we're back to that scenario where to find the inverse would not be easy. Switching x and y means I'd have to complete the square, blah. So if I want to find g prime of 5, I know that's going to equal 1 over f prime of something. The 5 is the f of x value. It's an x value of the inverse, so it was a y value of the original. We got to find the x value that goes with it. So I do that by setting 5 equal to x squared plus 2x minus 3. Set it equal to 0. 0 is x squared plus 2x minus 8. Factor it. X plus 4, x minus 2. And I get x equals negative 4, x equals 2. Which one do I use? Well, it says x is greater than or equal to 0, so x equals 2 is what I use. So 2 is the x value that goes with 5, which means my formula, 2 goes there. Okay, so now I just got to find what f prime is. F prime of x is 2x plus 2. So f prime of 2 is 2 times 2 plus 2. 4 plus 2 is 6. So this is 1 over 6. What do you think? Hopefully you're starting to get the hang of it a little bit. Okay, let's see where we're at here. Okay, so I think that's a tricky lesson. I'm actually going to hold off on doing this. We'll do all the inverse trig stuff on the next video tomorrow. So hold on to that page. What I want you to try today, so here's your latest problem sets. I tried to update it in class, but some of you might have an old version of the problem set. If you look down to 110, that's the next one we're doing. If it doesn't say worksheet 7.3 here, you might have a page number. It might say like page 544. I ended up making a worksheet instead of the book because I didn't like how the book explained stuff. So cross out any page number that was there if you haven't done that already and write worksheet 7.3 instead. The second part of this problem set is some inverse trig stuff. So I'm not going to assign or tell you to try page 586 yet, What I would like you to do is go to this worksheet, 7.3. You should have that in your homework packet. Try this worksheet, get that done. It's all derivative of the inverse stuff like we just did. And again, I did number 1 in the notes. I didn't do it specifically A, B, C, D, but if you follow your notes for that first example, I did those in that order. So that's how I want you to do all of these. Give those a shot. These ones down here, same idea, but with the quadratics. See if you can figure those out as well. Use the blue sheet answer key. Check your answers on there. Okay? And actually, now that I'm thinking about that, this might not be in your answer key. Let me double check real quick. Okay, yeah, I realized I copied an old problem set for you this year. So if you don't have worksheet 7.3 answers on your blue sheet, which I don't think any of you will, take a picture of this screen right now so you can check your answers as you go, because it's really important that you see that you're understanding what you're getting here. So those are the answers to worksheet 7.3. Just take a picture of those real quick, pause it, write them down, do something. But try that worksheet right now and see if you can get it. It's not going to be due until next week, but you do need to try it. Okay? All right, good luck. Email me with questions.